Hello and welcome. This is Dr. You Know Who, Chapter 13, the final chapter, Reasoning and Decision Making. Decision making, the biology of it. I know it says it's the biology of reasoning, but it's the biology of decision making. Ladies and gentlemen, this is the last presentation. Woo! Are you pumped? I'm pumped. Let's get talking about this. Now, this is some really cool stuff, okay? I'm going to present a few pieces of research. There's so much more research that one could present on this topic. And this is a really interesting topic because humans are one of the best decision makers. Well, so it seems, right? We can take so many different things into account that it seems like animals have no parallel to us. Especially even dogs or cats, even something somewhat similar to us. They typically, it seems like they think about pretty much the immediate, whereas humans, they think about the long term. They think about many other aspects, either that's consciously or unconsciously. So this is some of the research that's going to get at what parts of the brain are important to decision making. We're primarily going to focus on the frontal cortex. Why? Well, that is the main area of interest. So parts of the frontal cortex, in particular the prefrontal. Prefrontal is the thing that I'm tapping right now. If you could see me, I'm tapping my forehead. That's the prefrontal cortex, essentially, that little layer of cortex that is right above your eyes and right behind your forehead. Now, one part in particular, the VMPFC, the ventral medial prefrontal cortex. Okay, ventral medial prefrontal cortex. The ventral being the belly, the medial being the side. All right, so the lower part, side of the prefrontal cortex seems to be a very actual important location for a lot of this decision making. So we're going to talk about the VMPFC, or we're going to talk about the PFC right now, all right, just in general. So what researchers have found early on is that chimpanzees, when they are given a sample box to look at, a trial in a shape that they have to then later match using the same shape. So they're given the shape in the middle, the shape, and then they have to later match that shape in the next screen, or rather even in a situation where the blocks are in front of them, they have to pick the shape. Well, the individual will gain the reward if they pick the shape, but then they'll get negative feedback if they pick either of the other options. Now, that's funny, chimpanzee, monkey, there's a mistake there. So anyhow, these non-human primates, they can start to realize this quite quickly. If you start to change this and you do a color matching block, you give them the green, okay, and the green circle, and then later on you give them these objects. Well, what are they going to pick? Well, they don't know what to pick. But if they start picking and they start getting rewards based on the color, then they're going to start, what do you think they're going to do? They're going to start picking based on the color. So this is actually very, very similar to what's known as the Wisconsin card sorting task. I'm actually looking at it right now. I wish I would have plopped a couple of these images up there of that, but I'll bring this into class and we'll probably work with it. But it's the Wisconsin card sorting task. Now, the interesting thing is that chimpanzees who are normal, meaning that they're neurotypical, they have no problems with their brain, they will start to learn this task quite well, all right, as long as they're getting a reinforcement. Now, if they have damage to parts of their frontal cortex, especially the prefrontal cortex, they're going to have difficulties in learning this sequence of what the experimenter is trying to reinforce them to make their selections. Okay, so human parallel is called the Wisconsin card sorting task. Very, very similar as in this, and there you have it. Okay, so researchers have also found evidence for a lot of domains dealing with the prefrontal cortex. So problem solving, planning, understanding stories, as well as even reasoning. All right, the Tower of Hanoi is a small little game. It's a fun little game if you haven't played it. It's another thing where it has to involve problem solving, where you're given a stack of these little discs, and you have to move them all over to the right side in that same fashion, but only a smaller one can be on top of a larger one. You can't have a large one be on top of a smaller one. So there's a particular pattern. It's actually quite easy once you get the pattern, but if you don't know the pattern, you're going to have to do a lot of problem solving, working through it. Okay? All right, so let's continue on. So the prefrontal cortex also interacts with these tasks. Now, some tasks are really easy, some tasks are really hard. Now, if a person has brain damage, they might be able to, so like brain damage in the frontal cortex, they might be able to understand easy tasks. But if it's a difficult task, they may have a difficult time. All right, and that would make sense, right? So I want you to determine the order. So Sue is taller than Bill, and Bill is taller than Fred. Does that make sense? Sue is taller than Bill, and Bill is taller than Fred. Okay, I can mentally imagine that, right? Now here's number 2. Jack is taller than Bob, and Sally is taller than Jack. Wait, Jack is taller than Bob, and Sally. Oh, okay, Sally's taller. Okay, Sack. So it basically goes Sally, Jack, Bob. Okay, so that is a little bit more difficult, right? Number 2 is, and that's what researchers find. Not impossible, but a little bit more difficult. You have to take a moment to really think about where does Sally fit in to play with Jack. Sally and Jack. Now the thing is here is that people who have brain damage, they're going to have much more time, much harder time discerning the outcome for number 2 than number 1. So it also seems as though it's not only just brain damage, but if the task is difficult, then that's going to be problematic for people who have brain damage. Easy tasks, very easy tasks, might be somewhat simple even for some people who have brain damage. So here's some other research. I'm going to talk about some specific research, but here's just some general research. So the role of the prefrontal cortex in humans, you're going to have an easy task versus a hard task. You have participants without brain damage. You have participants with temporal lobe damage. So those individuals in the orange, they're going to serve as the control. You have the purple people, the purple people group. They're the patients with prefrontal cortex damage. So in an easy task, you see overall that most of the participants perform pretty well. People who have brain damage, just in general, either the orange or the purple, temporal lobe versus the prefrontal cortex, they do kind of similar rates. It's not as good as people who have no brain damage, but it's not terrible. Now you see a very interesting finding is that when the task is hard, you see the normal participants, they go down just a little bit, and that's fine. They're the same as those that have the temporal lobe damage. But do you see the participants who have prefrontal cortex damage? Yeah, they have a massive decrease, a massive detriment now to their problem-solving ability. And so this is definitely showing that there's an interaction here, such that when you're in an easy task, the damage doesn't seem to matter. However, when you're in a difficult task, the damage does seem to matter. And if you have damage in the prefrontal cortex, it's going to create a major problem. Alright, so now we're going to start talking about emotions and what role they have in decision making. And now we're going to start to get in specifically into a couple types of tasks that researchers look at, as well as the role of the ventral medial prefrontal cortex. Okay, so let's start talking about emotions and what role might they have to play in decision making. But again, in particular, ventral medial prefrontal cortex. That is what we're talking about here. Okay. So, how does the ventral medial prefrontal cortex influence decision making? I'm going to read a few pieces of information, of findings, basically evidence, and then we'll get into a study. So basically think about the ventral medial prefrontal cortex as an area where, if damaged, is reliably associated, so damage is reliably associated with a defective emotion modulation. Alright, so in respect to what's going on here is it's hard for people who have damage to their prefrontal cortex, ventral medial, to regulate their emotions. Specifically, people who have this damage have poorly controlled emotional responses that are not in line with the precipitating event, with the event that made them act that way. Okay, so people may jump to a conclusion very, very quickly and get very, very angry. Furthermore, these researchers also provide evidence that clinical descriptions of patients, who've acquired ventral medial prefrontal cortex, they just label it a little bit differently. This is like an old school way of doing it. Damage consistently indicate despite generally blunted affect. So they overall have generally blunted affect. However, in response to relatively minor provocation, so if they're provoked in any way by some sort of stimulus, they're going to be short-tempered, they're irritable, they're angry, may even be argumentative, and even abusive. And many researchers have found similar findings in people who have VMPFC damage. Okay, so going back to this slide, it does seem as though when faced with a annoying stimulus or something that is emotionally provoking, they may be quick to anger. Okay, so important to keep in mind here. So this is first piece of research. So what role then is the irrational economic decision making after ventral medial prefrontal cortex damage? So this is a game that the researchers are going to play. So this is basically the researchers are using their quotes from just a moment ago. These researchers are using what's known as the ultimatum game. Okay, this is a pretty cool game. If you never experienced the ultimatum game, these researchers are going to be looking at decision making, economic decision making, by people who have VMPFC damage as well as those who don't. Okay, so here's basically how the ultimatum game works. It's super simple to understand. Here's how the game works. Subject A, you get $100. You must offer some sort of split to subject B. Subject B can accept or reject. If she rejects, nobody gets any money. So basically, you're giving $100 to that dude over there on the left with that brown short hair. That guy right there, he's going to say, all right, I'm going to have, well, I can split this money any which way, and I can offer it to subject B. If subject B accepts the money, then she will receive that cut of the money, and then subject A will be able to keep his proportion of the money. But if she denies the claim, if she denies his split, then neither of them get their money. So it's kind of a funny game where, he's going to have to offer enough where he can maybe get more than, maybe 50-50. But, he doesn't want to do too much because then she might be like, yeah, F you, buddy. I'm not going to take that small amount. I'm not going to take that. And guess what? Now you don't get that money either. Okay? So it's kind of an interesting game. And a lot of people don't split it 50-50, but sometimes they do. So here's that's the ultimatum game. And so here's how the ultimatum game was used in this experiment. So they had 7, 14, and 14 participants. So 7 of them had the ventral medial prefrontal cortex damage. 14 had just brain damage, and 14 were neurotypical, meaning that they had nothing wrong with their brains at all. They were just complete control participants. So how does the VMPFC influence decisions? Well, it influenced decisions in this way. So overall, what the researchers were looking at is how would people accept, so this was only a $10, so the person A was given $10, and then person A would say, sometimes they would say, all right, I'm going to keep 7 and I'll give you 3, okay? Sometimes they said, hey, I'm going to keep 8, I'm going to give you 2. Sometimes people would say, hey, I'm going to take 9 and I'm going to give you 1, okay? Now the interesting thing is, to me, if someone offered that to me, like, unless I really needed the money, I'd probably say, yeah, buddy, guess what? You're not keeping $7 and I'm not getting 3. I'm probably going to deny it anyhow. I don't know, though. I mean, I don't know. I guess I would have to be, forced with the game. But that's how I would think I would do. But most people don't do that. The interesting thing is, most people actually accept those small splits. So they're not going to get too much money. So that's the normal controls. There is definitely some leeway between that average. The individuals who are the brain damaged controls, they're exactly the same as the no control, or sorry, as the control group. There's no significant difference. However, the interesting thing is these VMPFCs, these individuals kind of act like me, how I think I would act. I'm not sure what that's telling you. I got brain damage or something. But basically, what they do is they accept less of those small offers. Now, what does that mean to them? Well, what that means to them is, who's getting less money? The first, second, or third group? Yeah, it's a third group, which is interesting. They're getting less money. Now, why? Is that good? Well, it's good and bad. It's good in that, well, let's just talk about the bad. It's bad because they're not getting the money, okay? They could be richer. But I guess it's kind of good because they're not necessarily getting taken advantage of, right? Now, the interesting thing is they seem to be almost acting like, remember I showed you that slide with that red little emoji? Getting angry. So they might be a little bit more quick to anger when a person offers them that 3, 2, or $1 split. And so that's what researchers seem to be believing what is going on here. So VMPFC damaged participants reject more offers than the control groups. We just saw that. Likely because the VMPFC group is frustrated or angry with the proposal, just as I said. Okay, so I'll just focus on that for a moment to help let it sink in. So, kind of interesting findings that the VMPFC deals with emotions and may kind of help dampen the emotions or involve emotional control over stimuli that is coming in that might seem annoying. So important to be able to keep yourself under control, and possibly the VMPFC is the device that helps one do that. So let's think about some more real world decision making. So this is not going to be in the ultimatum game, but this is going to be actually in a really cool experiment where these researchers, similar researchers, looked at marketing and what happens when advertisements try to sway an individual to buy something or to consume something. So this is the prefrontal cortex damage abolishes brand cued changes in cola preference. Interesting. Let's continue. So what these researchers did is they didn't use the ultimatum game. They used the Pepsi paradox. Isn't that a great word? The Pepsi paradox. And what the Pepsi paradox is, it's basically just like what's kind of shown here. Well, no, it's not like, Pepsis are, kicking the, kicking the, I want to say kicking the can, kicking the juice or whatever you want to say, kicking the soda out of Coca-Cola and then, call Dr. Pepper. No, it's not that. It is really that in a taste test, most people, in a blind taste test, most people, what researchers find, they pick Pepsi as the better tasting product. However, when there's not a blind taste test, people pick Coca-Cola. Wait, what's going on? In a blind taste test, people pick Pepsi, but in a non-blind taste test, people pick Coca-Cola. What the heck is going on? So this is the Pepsi paradox, okay? And it's believed that Coca-Cola has better branding. It's been around longer. There's a lot better connotations associated with Coca-Cola, and so that's why maybe people are being swayed by the brand, by the label. So here's the participants. Okay, so they use the Pepsi paradox, which I'll explain explain how the researchers did it in just a second. But here are their participants. They had 16 control participants, again, neurotypical. 16 brain damage participants had some sort of brain damage, and then 12 who had damage to their PFC, as well as documented emotional processing issues. Now, in a blind taste test, participants, the participants were subjected to sample 2 unmarked cups, 1 Coke and 1 Pepsi. This was 20 trials. And the participants on these 20 trials, they had to pick out which little sip that they liked the most. Cup A or Cup B, and Cup A might have been Coke, Cup B might have been Pepsi, and they had to blindly rate which one they liked the most. Now, in a semi-blind taste test, the test subjects sampled 2 cups of the same cola. All right, this is kind of tricky. 1 cup was accurately marked with the cola's brand logo, and the other was unmarked. Okay, so for instance, on the first trial you got Coke and Coke. Okay, one was labeled Coke, and the other Coke was not labeled Coke. It was just left for you to infer. So, and then 20 more trials later, or 20 trials, also 20 trials, there was Pepsi and Pepsi. One of the cups was labeled Pepsi, and the other was unlabeled, but it was also Pepsi. So the participants had to say whether they liked the one that was labeled with Coke or Pepsi, or the unlabeled cup. Okay, so that was the semi-blind trial. Semi-blind because one of the cups they knew what it was. So the interesting thing is these are all the blind choices. So you have the controls, the brain damage, and then the VMPFC damaged individuals. On the y-axis, you have the percentage choosing Coke versus Pepsi. What you see overall is a little bit higher rates choosing Pepsi in the blind choice. Same here, and actually same here. Okay, so for blind choices, overall people do prefer Pepsi a little bit more, but there was no significant difference in the blind taste test among groups. Okay, that's the interesting thing. Among groups, there was no difference. All picked them at rates that were about the same. Okay, indicating that in the absence of brand information, all preferred Pepsi to a similar extent, but not massively greater than Coca-Cola. Now, let's go to the semi-blind. That's where it's going to get interesting. So the semi-blind is arranged in the same exact way. Control, brain damage, VM, PFC damage, and then on the y-axis you have the percentage choosing. Here, participants change their tune a little bit, the controls. They select Coke a little bit higher than Pepsi. Same with brain damaged individuals. Select Coke a little bit more than Pepsi. However, here, they don't fall victim to it. They don't fall victim to the Pepsi paradox. They are not swayed by the marketing. They still pick with what their taste buds say is the best, possibly. So, here's what the researchers said. In a 3x2 ANOVA, and ANOVA is just a way to analyze this data, of the semi-blind test, data revealed a significant interaction of group and brand label. Okay, and those are some of the statistics. Now, the interesting thing is group and brand label. Group would be the 3 levels: the control, control, brain damage, and the VMPFC damage people. The brand would obviously be Coke or Pepsi, indicating a significant between-group difference in cola preference in the presence of brand information. Okay, good. So yeah, definitely suggesting that something is going on there where one of these groups is going to be acting differently based on the Coke versus the Pepsi. Now, which one was it? Well, it was the PFC, the ventral medial prefrontal cortex group. They differed from both the control as well as the brain damage group at both significant rates, suggesting that their change in their behavior was not due to just by chance, but it was likely due by their inclusion in the VMPFC group, the damage to their VMPFC, in selecting a greater proportion of labeled Pepsi than labeled Coke, while NC and BD by the brain damaged individuals made nearly identical patterns of choices. So they didn't necessarily choose differently based on the Coke or the Pepsi. However, the VMPFC folks did. So what this is saying overall is, in a blind test, all participants preferred Pepsi a little more than Coke. In the semi-blind test, though, the VMPFC lesion participants still preferred Pepsi. So the reason that researchers propose, based on their hypothesis, is that this result suggests that the VMPFC individuals, or rather the VMPFC, is a critical neural substrate for the effect of commercial branding information on human decision making, meaning that this is some sort of area that is affected by the so the VMPFC is an area that is potentially affected by or rather detects creates some sort of pleasant emotion in you when you possibly see some sort of brand that you have that you've seen in the past. So when I see, I don't know, Patagonia, I've worn Patagonia for quite a number of years, maybe Lucky Jeans or something like that. I see that and I'm like, oh yeah, that's what I want, give me that. And it might be because my VMPFC is becoming active to some extent. If I didn't have my VMPFC, I may not like that clothing anymore. I may not need that clothing anymore. Kind of interesting to think about. So that's decision making and how the decision making may be influenced by that part of the brain. Okay. So let me move on to the last topic here. Okay. Boom. Yeah, set off your fireworks. The last topic here. These are other areas of the brain, and this is a cool little piece of research. These researchers looked at how is an individual's decision-making process influenced when they think they're playing against a real person or when they think they're playing against a computer. Okay? So we're going to look at some other areas of the brain, not so much the VMPFC, but this is called the neural basis of the economic decision-making in the ultimatum game. Now, if they were looking at this, they're looking at this just in respect to playing against people as well as playing it against a computer. So here's the participants, how they accepted the splits. So they were sometimes being told that they were going to be playing against a human, and sometimes they would be told that they were playing against a computer. Okay, and the computer can give out various sorts of splits, and the human can give out various sorts of splits. So here's the acceptance rates for if the participant. So if the if the first individual got 5 and then the participant got 5, the person A got 7, the participant got 3, 8, 2, 9, and 1. Okay, and what you see is overall at 5 and 5, yeah, you better believe it, man. You're definitely going to be accepting that, right? Because that's an even split. 7 and 3 is still about the same. Okay? Interestingly enough, whether it's a human or a computer offers you that. However, the interesting thing is, this is probably how I would definitely do it. If a computer offers it to me, I'd be like, all right, I'll probably accept it. The computer doesn't know better. It's not going to be able to spend this money. It's whatever. But if it was a human, I'd be like, wait, that person's going to get $8? I don't want them to get $8 and I only get 2. That's unfair. That's bogus. Now, it even drops a little bit further. Still, the people, they decrease it a little bit, which is great, right? Because they're like, oh no, I don't want that computer to get that extra dollar, man, that computer is going to have a good time spending that money. So they don't take that dollar, which I'd probably do too. I'd be like, yeah, what's a dollar anyhow? I mean, I love dollars. Like, I'll pick up a dollar for sure. But I think that's unfair, and I'd be like, oh, the computer's unfair. But the participants kind of say they're unfair, but they definitely say the person is unfair. Now, the interesting thing is, not necessarily, the difference is decreasing as time goes on, or rather as the offer becomes more unfair. But really, it's the difference between the last two conditions, the $8 and $2, and then the $9 and $1. Do you see that there is a massive difference between the differences of being a human versus a computer? So here, it seems as though humans seem to kind of evoke this sense of anger in an individual. Now this, and it's possible. So, why could this be? Well, it's kind of like I told you earlier. You feel as though you're just being taken advantage of. It's not just fair. It's not fair. But if a computer was doing it, then, whatever. The computer's not really thinking. But this other person is. That's just totally unfair. I'm not going to accept this. So, what is going on inside the brain? That's what these researchers looked at. Well, they found actual activity in two particular areas. One was just the dorsolateral prefrontal cortex. That's an area that's involved in a lot of things in respect to working memory, possibly. As we talked about earlier, right, the monitoring of working memory activity within other parts of the brain, as well as, though, we're talking about the anterior insular cortex, called the insula, oftentimes. Now, this area I'm going to point out right here, okay, and that's the area that is highlighted in blue in both of those cross sections of the individual's brain. So the insula may be important with a host of different behaviors and cognitions, but mainly experiencing of negative experiences, such as disgust, pain, as well as hunger. So what researchers looked at was the anterior cingulate cortex, all right, as well as the anterior insula, okay, as well as the dorsolateral prefrontal cortex. But we're going to primarily focus on the anterior insula and then the dorsolateral prefrontal cortex. So what you see is in the accept versus the reject, the accept was very, very low, the activity. The reject region, the activity seemed to increase within that particular location of the actual brain. Now, if you look at the dorsolateral prefrontal cortex, this is an area that just kind of seems to be active regardless. Okay, so it could be possible that it is activity within the insula that is help making and driving an individual also to kind of say, hey, this isn't unfair. This isn't unfair. So it's likely multiple parts of the brain that are involved with decision making. Now, anyhow, guys, girls, this is just a little primer at decision making and the biology of it. I would like to just recap here. Emotions seem to have an important aspect to decision making. A lot of people thought that once emotions didn't matter. Researchers are suggesting that they do to decision making. You cannot make a decision without actually having your emotions be involved. We talked about the role of the VMPFC. It's also important for monitoring marketing prior information, so marketing / prior information that you've come across. And you may take a computer less serious. You may not actually get as angry at a computer. And why is that? Well, it possibly could be related to a decrease in insula activity. When you get angry with someone, it could be activity with the insula in respect to disgust or annoyance with that individual, and maybe that's going to help drive your decision making. Ladies and gentlemen, it's been a pleasure. Thanks for tuning in. I'm out of here. All right.